Alright, I think we're connected. Let me just make sure, good title. Keep it as Breakout for now. Excellent, okay. Alright, so here we are. We want to start the game server, button dev. Just check my audio real quick. Alright, I think everything should be better today. Okay, try to reduce my network. Okay, so let's go home. Let's go to Breakout. And in here, so far we have left movement and we get blocked, and we have right movement and we get blocked. And so what we want to do is, actually we also have space. When you press space bar, it releases the ball. And then it resets. And so we want to consider doing collision on the we want to make sure the ball bounces off the paddle, but also off of the blocks. So, in order to do that, just give me a moment, I need to turn my volume down. Music's too loud for me. Alright, so we want to control the state of all the bricks. So we'll go to types, and we'll say bricks. And we wanted, I'm wondering if we just say whether it's true or false, but I'll just do brick. It's fine if we have more data than we need. Export interface brick. I'll just say is alive. So in here we'll do bricks array.from. We'll do rows first. What did we call it? Colors. Colors.map. We don't actually care about this. We only care about the row. And then we do array.from. Length is columns. And we'll do map. We don't care about that, but we do care about... Do we care about either of these? I don't think we do, actually. Honestly. Is alive. True. And so we can do... For the bricks. The background is conditional. The condition being we'll just say return color for now. background. So let's get the state. That's state. We'll say const is live equals state dot bricks sub row sub column is alive. Let's say if it is alive, then we'll do background, otherwise we'll do black. And so let's open the debugger. Nothing should really change. That's good. So I feel like maybe the ball just updates. We'll just keep everything in the ball's update. Maybe here we'll do detect paddle, detect brick. Excuse me. And so we want the ball to bounce off the paddle. I think we're gonna just treat the ball as a square. And we basically just need to see if, first of all, if the ball dot, state dot ball dot velocity dot y is greater than 0. Only if the ball is going down should we detect the collision with the paddle. And we basically just need to see if the two rectangles overlapped. So we say const. We gotta figure out like the intersection rectangle. In order to do that, we say min x, min y, max x, max y. We need to figure out these 4 values. So the min x is going to be the bigger of the two x's. Which I guess is a little bit complicated. Let's just think about it a little bit. We'll create a helper function for now. Actually, I wonder if I could just directly reference the paddle. This seems kind of dirty, but yeah, I'll do this. Yeah. This is very similar, except it'll be Y. Just align both of these. It's very similar. V dollar Y V dollar P. Alright, this will be X still, but it'll be plus paddle dot bounds dot width plus this dot bounds dot width. This will be min. This will also be min. This will be Y plus paddle dot bounds dot width. This will be Y height. This dot bounds dot height. We'll say if max x minus min x is greater than 0 and max y minus min y is greater than 0. Then we'll just say ball state dot ball dot velocity dot y equals. Just keep it very simple. Let's just see if it works. It should just have perfect bounce. Shouldn't matter where you're hitting it. We might even be able to like, I don't know, hit it on the side. Very difficult. But that's paddle. It's no longer a to do. We've done it. So next what we could do is trying to detect if the ball is hitting any of the blocks. Now we could write something that's very slow and just see what happens. So let's create a function. We'll say const collides equals a engine dot bounds. What do we call it? Rect. Get wrecked. Hello. Is this recorded? Hi. Hi. This is live. I am creating the Breakout game. How you doing, Yavraj? We're going step by step to create the Breakout game, which is a retro game about breaking blocks. Oh, Mr. Aether Gamer. Just eating a bagel. I also had a bagel this morning. I had a chicken and mayo on everything bagel. I guess like chicken salad on an everything bagel. Toasted, of course. What is your bagel of choice? Wish that this had. Plain cream cheese. Yep, that's my usual. We already had a can of chicken open, so I just wanted to finish that. But that's actually the usual. I got like a 4 pack of cream cheese and a 12 pack of bagels from Costco, and I've been just eating those in the morning. It's a very good breakfast. Alright, we're going to take a lot of this code from here and just put it into the collides function. And we'll just say return. And for all of these, it'll be a, let's just see if we could do it with a command D, C, A. And then this one too, C, B. One more. Nice. And so what we could do here, we could say paddle.bounds and ball.bounds. And then yeah, we can get rid of all this. And we can go even further. Get rid of that. And now we have it in one if statement. One if block. Yeah, the other day we made our own like frosting with cream cheese. Basically just like cream cheese and sugar instead of like frosting. It's very good. Very versatile. Next we'll say we only want to run this. Let's just do it. Let's just run it always. We just for this one, the reason we do this extra check is because we essentially don't want the ball to get stuck in the paddle and then for it to just keep bouncing up and down. We just want it to bounce up, and once it's going up, we're done caring about the collision. We can add other checks so it's not always checking for collision. Maybe check to see if it's a little bit closer before we go full collision detection. But there's no, we're not seeing any frames. I mean, it's not getting slower and slower. So, as long as we're not dropping below, oof, I caught it right at the end. Let's see if it's a loss. Cool. So you want to do, let's just keep it very simple. We'll do bricks dot for each brick. And we'll say const is alive equals brick state dot bricks sub brick dot data dot row. Or we're gonna need that. We're gonna need a brick to know some information. Breakout dot brick data row column. So we'll go to breakout and do export interface brick data. Row is a number. Column is a number. Go back down to here. I question dot brick dot data brick dot data dot column. Dot is alive. If is alive and collision collides. And then we'll do paddle, or sorry, ball dot bounds, do brick dot bounds. We're gonna do fairly simplistic collision detection. We're just gonna reverse both velocities of the ball. I just want to see if it really hurts performance. Okay, cool. And then the other thing we need to do is what we want to do is say const cell equals cell. I do if cell. That way we could take that off. And then we could say cell dot is alive equals false. Basically impossible to hit 2. At this point. It's kind of rigged. Ooh, almost hit 2. Alright, this one should hit more than 1. Should. Oh my goodness. Almost there, almost there. Alright, this one has to hit more than 1. Oh my gosh. Maybe it never does hit more than 1, because it always goes back exactly the path it took. So it'll never hit more than 1. Yeah. And that's just because we just bounced the ball, both on the X and the Y. So we need to do some kind of extra calculation to determine which one we should reverse. Alright, so const is X bounce. That's basically what we need to figure out. The question is, how do we know? How do we know if it's an X bounce or a Y bounce? There's also what to do for here. That ball to velocity. This is for the velocity X. This is for bouncing a wall. This one is bounce ceiling. This one is out of bounds. I feel like we should update the ball first and then do all this. This is a to-do. Where do we bounce paddle? This is a to-do. We wanted to make it so the ball... Oh, we lost it. It went all the way through and out of bounds. Make sure the ball bounces based on position. And then also space. To do make this random-ish. Okay, cool. Alright, let's do each to do. Bounce properly. So what I'm thinking is we should actually, the collides should actually maybe return the collision, and then we'll see which collision was larger. If there was more of a width, we could say width, height. What we'll do is const width equals, that's not the word width, const height equals max y minus min y, and this will just be width, height, and it'll be width greater than 0 and height greater than 0. Then we'll give this, otherwise false. And we'll go to collides. We'll say const collision equals we'll do we could do this. If collision this is the paddle, so we didn't need to do it here. So we'll just put these back where they were. We need to do it here. And so what we need to do is const collision equals is alive. And it's just gonna be this. We'll say collision. We'll say collision dot width is greater than collision dot height. Then so if the width of our collision is wide, that means that we hit it on the bottom or the top, which means that we need to do a y bounce, so it's false. We don't even need to do that actually, we could just do this. It's an x bounce if the height of the collision is bigger than the width of the collision. Let's try it. Alright. I think we want the ball. Oh, what just happened? I missed it. I think we want the ball to move a little bit faster than the paddle. I think the perfect bounce is kind of boring. So we did that. Let's see. So for this, we kind of want it to bounce some kind of circular formula. So you have to think about it a little bit. We want it to be some kind of like radial direction based on where you hit it. To where if you hit it from the middle, the radial direction goes straight up, but if you hit it on the edges, maybe it goes at a 45-degree angle. And so let's start to theorize potential ranges here and formulas. We're going to be setting the x and the y here to some values that we don't know yet. We're going to make a variable called const ball speed. Set it to 100. Find a number 100. Ball speed. Ball speed. This should also be random, radially. So maybe we make a function. Get ball bounce. And basically what we'll put in here is some number between 0 and 1. And we just need to figure out what would be, we would need to multiply theta equals math.pi times percent. And then we want to return x is math.sine theta, y is math.cosine theta. Something like this. This is a rough sketch. We just want to get the code in there just to, so that we can start playing around with it a little bit. And so we could say ball speed okay, so we'll do const velocity equals get ball bounce math.random, and we'll say velocity.x velocity.y, and this should probably apply the ball bounce. Okay, cool. say const get ball bounce. So it'll be velocity equals get ball bounce. We'll say 0.5, so it'll go straight up. We'll say velocity dot x, velocity dot y. And so in here, we kind of need to figure out, well, when it's 0.5, we'll think about percent equals 0.5. We want that to be straight up. And so we're thinking about, what do we do with pi so that cosine becomes 1? Well, cosine is 1 when this is 0, when pi becomes 0. And so maybe what we want to do is, let's just try percent, and maybe we do minus, and we do math.pi times percent. Maybe it's 2 times pi. We'll just put that for now and just see if it works at all. Maybe we want this to actually start at negative pi. Start it at negative pi. I think negative pi is too far. I think we'll do divide by 4. Alright. And then it's going to go from negative pi to positive quarter pi. So what I'm thinking is actually we'll do plus percent times math dot pi divided by 2. And that'll bring us in that range of going from quarter to pi to positive quarter to pi. Because when percent is 0, then pi would be 0 here. Let's put this inside. It doesn't want it inside, interesting. Cool. And let's just see, let's see what happens. Okay, so it is the wrong y direction. So we'll just try inverting the y. Okay, we want it to move a little bit faster so we can get more feedback. Oh my gosh. It's alright, I mean, it's whatever. It's definitely too fast for this game. And it does bounce straight up when it bounces off the paddle, but you know, apparently 500 is too much. And so we want to look for our other to do. We've made this randomish. And so we want to figure out how to determine this range. And so what I think I want to do, we got to think about the collision range of this paddle and ball. And think of the leftmost position that you can collide with, which I think well, all we care about is the x. And the min x is going to be the paddle dot bounds dot x minus the ball dot bounds dot width. That's the tiniest x that we can get. And then we can say const max x Actually, is that the tiniest? Because we can actually only go as low as half of the ball's width, because we're going based on the center of the ball. We want to figure out where the center of the ball is, not the left X of the ball. And so where is the center of the ball hitting? This is if it's hitting like the side of the paddle. And we're trying to determine where is it going to go if it hits the side of the paddle. The center of the ball will be there, which is where the paddle is minus the ball's radius. And so the max X is going to be very similar. Paddle X dot bounds dot X plus paddle bounds dot width plus ball. Or just say radius. Let's create a variable called radius. Okay, so we figured out the range. And then we say const x equals the ball's x I'm just realizing that we're not using this, which maybe is fine. It's fine. Find min x equals. So we're trying to figure out where the ball's center x is, and it's going to be its x plus the radius. And so this, in order to get a range, we're going to do max x minus min x divided by x. Except the x is going to be minus min x as well. Let's do it in here. I think that guarantees us a range that we want. The ball speed is too fast. We got to think about how many pixels per frame is going to move. Okay, that's the issue that we're running into right now. If we are running at 24 frames per second, if we go to the console, if we're going 24 frames per second, that means in a single frame, we'll do 1000 divided by 24. In a single frame, that's basically, no, what is it? What if it's, yeah, this many seconds is what passes in a single frame. If we take that and multiply that by 500, that gives us 20. Right? If we look at the brick height, the brick height is only 10. And so in a single frame, the ball has the potential to go 10 more than the height of a single brick, which is certainly problematic. And so it would probably be a really good idea to either make the bricks thicker or to make the ball slower. But ultimately, just to make the ball speed based on the brick's height would ideally be the best, I think. Because it also has the potential to just go right through the paddle as well. And so we want the ball to go as fast as the thickness of the paddle or any brick in a single frame. And so we need to figure out the inverse function for that. So brick height is going to be important for this. And something about 1 divided by 24. And so if we just take brick height, let's just see what it looks like. It actually, this is going to be so slow actually, when I think about it. What if it was this? No, because then it'll just be like 2. So we want to choose a number where in one frame it becomes, I don't know, let's see. Okay, it's still too, it's still destroying our board. Ay. Ah. Well, when it moves unpredictably like that, it's really hard to figure out where to move your paddle. Let's just contlog the ball speed. Just give me a moment. Okay. Let's do a refresh. Alright, well, we're at 416, which is less than 500, which is what we had before. Let's just pretend we're going. Let's just say we're going 20 frames per second. Okay, if we're going 20 frames per second, it goes even faster. And ideally, if you increase the frames per second, it should decrease. Because we don't want the ball, if it's only 1 frame per second, that means we have an entire 1000 seconds to move the ball. And that means that the ball has the potential to move even further, which means we need to make the ball go slower. And so because this number gets smaller the more frames we have, that's not ideal. Which makes me think the frames go on top. It's definitely not 2.4. Let's just see what this does. Oh, it went through the paddle. Alright, maybe we don't do a formula. I can't quite think of what it should be. Just make it 100. 100 is so slow though. What if it was 200? Well, we basically have a formula right there on the screen. We basically have like 1 divided by 24 times 250 equals 10. Where this is ball speed that we would want. No. This is brick height. This is ball speed. So we could just figure out from here. We could just take this, divide by that. What we could do times 24. I guess that makes sense. Yeah. I will say const FPS equals 24. Oh. Try to hit it near the center. I failed. Okay, it seems to be kind of going the opposite direction I expect. That looked right. Ugh. That's a really bad angle. Alright, let's look for space. And we'll do a else state dot ball dot position dot velocity dot x equals 0. We're just gonna add some test states here. And we're also gonna do say const percent. Then we'll console log the percent. Okay, so the percent definitely should never be more than 1. So we need to figure out why we're getting the value 2. Right, that's the only console log, right? Yeah. Alright, so the radius is the ball bounds width divided by 2, correct. The min x is the bounds x of the paddle. Okay, so this seems to do what I want. Okay, so it's definitely an issue with this code. Let's go back to thinking. Ball's width divided by 2 is radius, correct. The smallest it could possibly be is the paddle bound x. Now the paddle, no, these are the bounds. We can't draw it differently than the bounds. We add the radius to the ball x, so we get the center. Take the paddle bounds plus the paddle bounds width, x plus width plus radius, get the maximum. take the balls x. Max x minus min x divided by sorry. It's gotta be on top. Sorry. Oops. Interesting. Alright, it's still a little too fast. It's causing multiple collisions. And since we're not like dropping frames, I'm not too concerned about optimization. But I think one thing I should consider is like having some kind of undo. Maybe the velocity. I'm trying to think if like the order matters here. Should the velocity increase first and then we detect a collision, or should we detect collision and then change the velocity? Maybe I should do both. I wonder if we should just like divide by 2 here. I know the ball's gonna be really slow, but we don't have to worry about double collisions. Nah. Alright, so maybe we should have a function called apply velocity. I don't know. There is something that is like obviously happening where like it seems like the ball kind of goes on top of the thing, the brick for a moment. But maybe it's just because we have this debug state on. It just looks like that. Where's bounce paddle? Maybe there's something wrong with collides. Eta x, beta x. Eta y, beta y, min y. Max, max, min, min, max, max. Eta x, eta width. Beta x, beta width. Eta y, beta height. Eta y, beta height. minus min y. Max y minus min y. With height greater than. With height. Looks about right to me. I wonder if we should apply the velocity again, or if we should like push the ball out. Hey Sadiran. Sadiran? Sotiran? Isn't it something with order of operations, moving the ball before checking for collision? That's what I was wondering. I'll try it. I'll check the collision, then I'll move the ball. What if I should make it move slower? It still looks like it's like deep in there. Oh no, I lost it. Oh, was so bad. Cool. Hi. Yeah. It still looks about the same. I'm trying to think, is there a way that I could just run it slower? In theory, yeah. If I go to the engine and I do, I don't know, delta time is 1 divided by 60. Is it? No. Is that right? Is that right? I don't even know. Engine from scratch? Yeah. We're trying. We can certainly implement that feature. A power up to increase the size of the ball. It's just for fun, just for learning. I don't predict that anyone will ever necessarily use this engine, but it's a good learning experience just so you know what's happening under the hood. Yeah, me. I do it. Self-torture. I'm having fun, yeah. What do you mean? It is, I think it's a good learning experience for sure. Because I get to deal with problems like this, figuring out order of operations. How does collision detection work? Yeah, I guess so, yeah. It's like saying manufacturing a car engine from scratch in a basement is fun. I mean, for some people it is, I would imagine. If they could do it. I mean, I'm trying to pass the time. I'm in between jobs right now, and I got like nothing to do while I wait for interviews, so just want to stay sharp. Um, and a lot of people on Twitch like watching games, so maybe they'd be interested in watching game development too. So we want... Thank you, thank you, thank you. I have an interview at 12:30 today, so I'm probably gonna have to sign off soon, but I'll be back later today. 1v1 PvP. I mean, who says we aren't? I'm trying to be remote though. I don't know if you're going remote, but that's my ideal right now. I think we're trying to figure out how many milliseconds. Maybe it's just 60. How many seconds have passed in this frame? I'm curious why not always doing this is not okay. Why is it unhappy? Just instantly shoots over. Instantly lose the ball. Is it supposed to be this? I just want things to go slower. That's faster. 10. Could it be something with collision happening between frames of the ball, between where it was last drawn and the next frame? Where it'll be, yes, it certainly is. I think that we update the movement, we update the position, and then we check for collision. But ideally, we should probably update the position again to push it outside of the object. So it's definitely something like that. But if we could just see it in super slow-mo, it might not even happen in super slow-mo. Yeah. Unless we make the ball really fast and keep it in slow-mo. We'll just say, yeah, there should be 60 now, right? It's still too fast to see. Alright. Yeah, we need to do some kind of like amendment, some kind of correction. So that that doesn't happen. I think another part of the problem is like the order that we hit, that we think we're hitting the bricks too, because it might go far enough to hit the brick above it, and if we process it in order of, you know, the bricks from top to bottom, when we probably should have processed from bottom to top, we might make a collision that we don't mean to make. So, like, to some extent, it might be better to just make the brick thicker and move the ball slower. It still, like, goes too deep in there. Don't you also need to update the location of the next drawn frame should a collision occur before the next frame? I guess so. We could try something like that. It'd probably be somewhere in here. We gotta do some kind of position correction amendment thing. So we're detecting the bricks here, we're detecting the correct bounce here. Just work in IT. No, I mean, it's, I think you have the right thoughts. I'm just hoping that I don't have to do that, because it just seems complicated. I'm gonna also increase the width because otherwise it looks too thick. So I guess what I'm thinking here is when you hit, we're kind of zoomed in here, so maybe we can see. Wow, it just plowed right through them, which is incredible. We might want to add we might want to add some kind of check to make sure we haven't already collided with something. Maybe we only want to collide with one thing at a time. But so if there's an X bounce, need to whip out the math. Yeah, for sure. So what I'm thinking here is we want to know where the ball is with respect to the actual block. So let's say amend. Can we do that? We can't just change the collision. Yeah, that's another complication because we're just using debounds. Okay, so I'm gonna create a new function, amend. And it's gonna, we could just use the ball directly. We just need state. And this will be, I have an idea I'm gonna try. And it has to do with like just taking the ball and just if you detect the collision, you just correct it as well. In addition to everything else, you correct it by pushing out outside the block. And so the state will be breakout dot state, and then we need to know what bounds we're amending it to, which is a rect. Engine dot rect. And so ideally we would be able to say amend I think since we already have the collision, we might need the collision too. I think that'd be nice. Maybe the collision should also be erect. We'll find amend. Say that this takes, come on, collision, which is erect, and engine direct. And so when we update the ball, we'll say amend state paddle dot bounds and then collision. And now we're gonna have to do this. We're gonna have to store this collision. Const collision. Amend. And then this is going to be collision again. This will be CID brick bounds. Just referencing the correct collision. Good luck with the job market and your engine. I gotta go. Okay, see you. Thanks for stopping by. Alright, so we have these functions. I do want to go back to 10, 50, this, because otherwise it's just too big of a game. Okay, cool. And so when we amend, we need to take the ball bounds and move them with respect to the thing that we're colliding with. So the question is, what does that look like? We have the collision intersection, and so that's going to tell us what to move by. But we kind of need to know what side of the rect that we're on. So we'll say const ball center equals ball dot bounds dot x plus radius, which is not a variable that exists yet. All we care about, no, we care about amending the y as well. We'll say ball radius ball dot bounds dot width divided by 2. Ball radius, let's say const ball center y equals ball dot bounds dot y plus ball radius. And then we'll say const bounds center x equals bounds dot x plus bounds dot width divided by 2. Const bounds center y equals bounds dot y plus bounds dot height divided by 2. And then now we're determining, should we push it out to the left or should we push it out to the right? If the ball radius is less than ball center x is less than the bounds center x, then it's gonna be, we gotta push it to the left. So it's gonna be minus collision dot width. Otherwise, it's collision dot width. And then we do the same thing for the y. Y, height, could just do negative 1, 1, so the line is smaller. And then we'll do the updates. So we'll say state dot ball. You know what? We'll do I. Move X. Move Y. And we'll do, let's see, collision dot width multiplied collision dot height multiplied. So state dot ball dot x plus equals move x. State dot ball dot y plus equals move y. And then it's actually dot position state dot ball dot bounds dot x plus equals move x. State dot ball, it's not state, it's just ball. Ball dot bounds dot y is plus equal to move y. Okay, looks worse. Because we should only do one or the other. We shouldn't do both. We shouldn't amend both. We should only amend one or the other. So let's say if collision dot width is greater than collision dot height. If the width is bigger, we do the x amendment. No, we do the y amendment. It's still moving so fast I can't tell. The width is greater, that means that it hit it from the side. Does it? If the width is greater, then it hit it from the top. Yeah. We can calculate this in here and calculate this in here. Which means we can calculate this in here, calculate this in here. Less calculations overall. Alright, let's put a breakpoint in the amend. Let's do a refresh. So the odds are that the width is going to be greater. Okay, so we have it supposedly colliding right now. We haven't drawn it yet. We'll draw it next frame. But we did detect that the width of the collision is greater than the height of the collision, which means it did hit from the bottom. And so when it hits from the bottom, we care about the y. And so it's in the thing, so the move y should be positive. Is it? It is positive. The ball's position After this adjustment, I feel like the ball's position should be fairly round. It's not. Is it because we're doing the center? No, because we're doing the collision detection. We've already done the collision detection. Well, this becomes fairly round. This is 139. This is 149. Why is it 10 off? Oh, it's probably because I move it before I... Ah. Alright. That's probably it. At least that's probably part of it. Actually, I mean, if we followed the other advice and just did this later... No, because then we would show the collision. That's fine. Okay, I'm happy with that. That looks a lot better. Oh! Interesting. Oh no. Ah. Okay, I don't think there's like... I don't think it's perfect, but it's pretty good. I just want to get upstairs. Just go. Alright, I'll take it. I think that the bounce off of them needs to be maybe a little bit more dynamic. We could probably do more. Ugh. Gosh, what are the odds? Oh my goodness. Come on. Alright. Well, we got collisions that I'm fairly happy with. Okay, let's go. I wonder if I should change this back to be, we can only detect one collision. If not collided. I think weird things happen when you collide with more than one. This song. It's too much for right now. Alright, we got collision. Alright, get status, get add. Add collisions and amendments. Alright, so there's a few more things we could do, but I'm not too sure what's really interesting right now. Const restart equals. This should take state. This will be breakout dot state. Alright, I gotta take a break in 10 minutes. Say restart here. We'll do lives. What else is going to be new? Score. And here we'll say lives. State.lives equals 3. And then state.score equals 0. We'll just make this an empty array for now. And here we'll say state.bricks. We'll say restart bricks. Const restart bricks. State breakout dot state. And then we'll say state dot bricks equals we'll go to the state and then we'll add these new properties. Lives number, score number. Okay. So we can display the lives somewhere. say x is 0, y is 0. Text is state.lives. This is a breakout.state. And then we'll say color is white, font is 24 pixel, courier, new. Let's keep it simple. Lives. Cool. And then we'll do score. Score. The y is going to be width. I'll say minus gap. And we'll say the xy is also gap, I guess. The x is, this is wrong. It's actually here. And then we'll say align right. I didn't add it. Score. Okay, and then what we're gonna do is whenever you break a block, you'll get some points. So we want to say const points equals, we'll do state.score plus equals brick dot row dot data dot row minus colors dot length, have that backwards, minus 1. We'll say const multiplier, and we'll do 100 times math dot pow 2 to the power of power. And so if you hit the front row, you'll get 2 to the 0, but if you hit the back row, you'll get 2 to the 6. That's the idea, at least. That was interesting. Ah. Oh, am I getting lucky? A little bit. Might be a little bit too many points. Just a little bit. say lives. We'll just say lives. And I think when we hit the paddle, we're gonna do state dot bricks dot flat dot find brick dot is alive. We'll say if we don't find one, then we'll say restart bricks state. Okay, so that handles a few things. It handles score. There's also out of bounds. We'll say O state dot lives minus minus if state dot lives. If there's no lives, then we'll say restart state. Okay. And that handles lives. It handles resets. Cool. Let's check. So that's 10, 20, 30. Great. So that works. The one thing I don't really feel like testing is whether it resets or not after you clear the board. Because it just takes so long. If only there's a way to kind of like debug it. Oh, I'm gonna run out of lives. Just want to get it in that corner. Oh. Yeah, that's a hard one to test. Add lives, score, and restarts. Cool. Alright, I need to hop off for an interview. I'll be back in about 60 minutes, 1 o'clock Eastern time. Thanks for joining in for now. I'll see you in a little bit. Bye!